Okay, so this video is for page 311 of the homework. I'm going to go ahead and answer number 2. For this video, I'm only going to answer, I think, 3 problems, one from each section. So this is for the section for 1 through 6, numbers 1 through 6. They give you these set of directions. Determine whether the given point is a solution to the equation. In class, we talked about ordered pairs. And we said that if an ordered pair is a solution to the equation, then that means it must give you a true statement at the end. So the easiest way to do this is simply plugging in your x and your y coordinate into the equation. In other words, let's go ahead and substitute. Here we have an x and here we have a y. Therefore, if we go ahead and plug those two values in here, let's see if we get a true statement. My y here is a 7, so I'm going to go ahead and replace this y with my 7 here. Now the 2 here is only copied down because it doesn't change. My 1 is my x, so I'm going to go ahead and substitute that 1 in for the x. And then I'm going to write down my 5. So therefore, I'm going to go ahead and follow what these directions are telling me to do. This is telling me to multiply, so 2 times 1 is 2. And I'm going to bring down the 5. So now 2 plus 5 is 7. And here, clearly we can see that this gives us a true statement. 7 is equal to 7. Therefore, this point, 1 comma 7, is a solution to the equation. So the answer for number 2 is yes, it is a solution to the equation. Remember, this is not enough. For you to write this is not enough. Technically, yes, I get what you're saying, but you need to answer the question. The question is asking you, is it a solution? And you have to indicate that it is. Okay, so that would do it for numbers 1 through 6. Now for numbers 7 through 15, the directions are find 3 solutions of each equation. So find 3 solutions of each equation. I'm going to do actually number 8. Okay, so number 8 is this. So the easiest way to do this is simply pick a random number, the smallest number I would say. So let's start with number 1. If I pick number 1 for x, what is y? What is my output going to be? So my input here is 1. I decided to pick some random value and I called it 1. So now if we go ahead and multiply 3 times 1, we get 3. So 3 plus 2 is equal to 5. So therefore my y value now is 5. So one solution to this equation, y is equal to 3x plus 2, would be 1 comma 5. 1 is my x, 5 is my y. So here's one solution. Another solution could be, let's pick another random number. I'm actually going to pick number 2. I'm going to go in order. So here's another solution. Let's actually move the camera a little bit. So if I go ahead and pick 2, so let x equal 2. Here I had let me actually start telling you what I let. Actually, I didn't let it equal 2. I let it equal 1, right? So this one is 1. This one is 2. Let's see what happens here. What would be my output? So 3 times, and I'm still using the same equation, 3x plus 2. If I substitute that x with 2, I get 3 times 2, which is 6. Bring down the 2. So now 6 plus 2 is 8. So therefore my new y output is 8. So 8 will go here, and my input was 2. So my new order pair, my new solution of the equation is 2 comma 8. Remember, these are all arbitrarily picked, meaning they're just kind of randomly selected. I just thought of a small number and I decided to call that my input. So here's another input. I'm actually going to write down the, well, sort of the equation because I'm missing the variable x. But what's my new input going to be? Let's call that 3. Since we already did 1 and 2, I'm going to go in order. We don't have to do this. You could pick 100 for all I care. The only thing is that you're going to find yourself dealing with big numbers, and that sometimes gets a little messy. But it's doable. So 3 times 3 is 9. I bring down the 2 is equal to y. 9 plus 2 is 11. So y is equal to 11. So here's another solution to the system. To the equation. So our input was 3, and my output was 11. So 3 comma 11. Let me write this with a better marker. 3 comma 11 is my solution to the equation. Remember, these 3 solutions mean that once we were to decide, and you don't have to do this on your paper, but I'm just letting you know. This line right here, 3x plus 2, is actually a linear equation. Therefore, when you graph it on a coordinate plane, which we discussed in class, that means that you're going to get these points. They're all going to fall on the line. And I'm actually going to go ahead and prove it to you. You don't have to do this, but I'm going to go ahead and show you what I mean by this. And actually, you know what? I'm going to go ahead and do it on graph paper. Therefore, it's a little bit neater. And start complaining about how messy it gets. So let's see. I'm actually drawing my coordinate plane because I didn't have it ready. Sorry. So here's my coordinate plane. Right. Let's see. My equation, or my linear equation, was y is equal to 3x plus 2. Right. Let's get a pen because obviously you can't see this. See, that's why I like writing marker when I'm actually doing these videos. Okay, so my first solution, right, if we think back to what we got, was 1 comma 5. So 1 comma 5 is the solution to this equation. Another solution we came up with was 2 comma 8, right? And another solution we came up with was 3 comma 11. That means all of these, when we plug them in there, they give us a true statement. How do we know that they give us a true statement? Because they must fall on the line. Once we graph this line, it must fall on the line. So let me show you what I mean by that. Here's 3. And I'm going to actually trace this down a little bit so that you see what I mean by this. Here's my x and my y. So I'm going to go ahead and graph this. Here is 1, 2, 3. Here's my x, right? Now I'm going to go up 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Perfect. Barely fit on the graph. So here's my ordered pair. It's 3 comma 11. Here's this one. I just graphed that point. Now 2 comma 8. 2 is here. I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. Remember, I'm doing these little dots here. So you don't have to do them. I'm just showing you how I went about and found this point. 2 comma 8. So the other one is 1. Here's 1. 1, 2, 3, 4, 5. The other one was 1 comma 5. When you connect these points, you get a straight line. Linear means straight. Therefore, just to visually prove to you, these actually create a straight line. So that's why they become solutions to this equation. Now remember, you don't have to do this for homework, but I did it because I wanted to show you a little bit more about what these points that we just found, what these points actually mean. What does it mean to be a solution? It means that when you actually graph them, they actually fall on the line like I showed you here. Do you see? Okay, let's move on to numbers. What are the numbers? 16 through 27. And I know you guys are doing odd, but I'm doing right now even because, I'm not going to do the homework for you. Okay, so actually I'm going to go ahead and do number 18. So here's 18. Oh, it's actually plus nothing. So the problem is just, and let me rewrite this. Then you're going to get confused. Y is equal to negative 2x. Okay, so make a table of solutions and graph each equation. We're pretty much going to repeat the process of what we did earlier, and then we're going to go ahead and graph it, okay? So let's go ahead and create a table, and I'm gonna go ahead and do my table. Remember, I required you guys to do this on graph paper because it's better, it's neater when you do it in graph paper. So here's my y is equal to negative 2x, okay? So let's pick a random value. I like picking negatives and positives so that we see both sides of the graph. So I'm actually gonna pick -1, -2, 0, 1, and 2. So if I pick -1 and I go back to my equation, let's go ahead and graph that. I'm gonna go ahead and do some side math. So let's see what my output is. My input right now is -1. So I'm gonna plug that in here. -2 times -1 will give me +2. So y is equal to 2. Therefore, my y value here will be 2. So my order pair, my first order pair will be -1, 2. So I'm actually gonna go ahead and graph that here. Here's -1. Here's -2, -3. Here's a +1, 2, 3. And I'm not going to go ahead and label the entire table. It takes a long time. I'm just showing you what I mean. So -1 is right here on the left side. And then we're going to go up because it's +2 for the y value. So here's actually my first point. -1, 1, 2. So this point represents -1, 2. Okay, so let's actually keep on going. -2. What happens when I plug in -2 into my linear equation? Well, I'm going to do some side math right here. Y is equal to -2 times -2. So here I get -2 times -2, which is 4. So y is equal to 4. Therefore, I'm going to go ahead and graph that point. Here's -2 for the x value, right? So here's -2 for the x value. I'm going to go up 1, 2, 3, 4 units. So here is a point, -2, 4. Now let's see what happens when you plug in that 0. So let's do some side math, okay? Here is y is equal to -2 times 0. Any number times 0 is just 0. So here we get also 0. So 0, 0 is another ordered pair, and that point is right here. Ignore that, please. That wasn't supposed to be there. So this is not a point. Okay, please ignore that. The point here is 0, 0, which is in fact the origin. So this line actually crosses through the origin. Let's see number 1. If we plug in a 1, right? Here is my a little bit of side math again. I'm going to put in a +1. So -2 times a 1 is -2 still. So now my y values turn out to be negative. So 1, -2 is my new value, my new order pair. So here's my 1 for the x. But now I can't go up because y is negative. So I'm going to go down 2. So here's my 2. Now, what happens when I plug in, right? What happens when I plug in? And I'm going to go ahead and do some side math up here. Sorry, I'm getting a little bit messy, but I'm running out of space. So y is equal to -2 times a +2, right? Now we want to input a +2. Well, -2 times a 2 is -4, so my output is -4. Therefore, my new order pair is 2, -4. So where's 2 at the x-axis? Here it is. And I'm going to go down 4. Here it's 1, 2, 3, 4. So now, as you can see here, these points, when you connect them, sorry for the messiness, but they actually form a straight line. Okay, so the directions said to make a table of solutions and graph each equation. Well, here we have a table and we graphed it. So this is what you would do on your paper. Now remember, I picked -1, -2, 0, and 1. You could pick -5, -2, -3, whatever you want. As long as you do negative and positive, I'm okay with that. And you include the 0. Okay? So remember, try your best and forget about the rest.